Okay, so we're just picking up where we left off last class. What we coded up here is a simple, hopefully a simple program that has a class in it called ratio. A ratio consists of two data fields, a numerator and a denominator. And just a little review on constructors. We supplied three constructors here. We have a constructor when you create a ratio and you don't supply any information. You will by default have the numerator set to 0 and the denominator set to 1. We decided that was a default ratio. We didn't like the idea of taking the default values we would get if we didn't write this constructor, which would be a numerator of 0 and a denominator of 0. And for reasons in mathematics, we don't want a denominator of 0. You could also create a ratio by supplying one value. Like if you said ratio and passed in a 3, that's basically you're saying 3 divided by 1. You don't have to supply the denominator, it will default to 1. So we have another constructor, ratio, we pass in one value. The numerator is set to whatever value you passed in. The denominator is automatically set to 1. You could also create a ratio by passing in two values. You're passing in the numerator and the denominator. If you pass in both values, the first value you pass in becomes the numerator, the second value you pass in becomes the denominator. And then we decided we're going to have two methods. One method is going to be called print numerator. So if you ever have a ratio and you decide you want to print the numerator, you can. You just take the ratio of the print numerator method and you print it. We also have another method. Let me just scroll down so we can see this. But this is print the value. This will print the value of the ratio. And the way we've decided to do this, remember now, these are methods we're writing ourselves, so we could have done it any way we want. We could have printed out the numerator, then printed out the slash character, and then printed out the denominator. That's one way to print out a ratio. Another way, we decided to do a computation. We took numerator divided by denominator, moved it into a float called value, and then we print out value. So there's two different ways we could print out the value. Okay, now I'm just going to skip over this, because this is kind of the topic we're talking about this class, is what are interfaces. But we have another class, because we want to demonstrate the use of the interface. So we have another class, and this is just a complete waste of a class. But what this is we created a class called myInteger. It's like our version of an integer. And what is it? Well, it has one field called of type integer. So normally an integer is something where you can store an integer value. Here we created an object which has one field, an integer, and that's where we can store the value. So it doesn't really do a whole lot, but it helps demonstrate the point we want to make here. We have a constructor, or we have two constructors. We have a constructor that takes in, if you give it no value, it will assign by default the value to 0. And then we have another constructor called a constructor that takes in one value. If you give it a value when we create one of these, we just copy it into the value field. There's not a whole lot going on here. This is just an integer class that holds an integer. But the compiler already gave us the primitive type integer, so we don't really need this. And Java actually, for reasons if you ever need an integer with a reference, like when you're calling functions and you want to swap values, you actually need a reference, you don't want a primitive type. They actually have a type called integer with a capital I, which is just like this. So we're just mimicking that class. Now in this class, we happen to have a function by the same name, print value. Same function here. So we did this kind of on purpose. We chose to have the same exact method name because suppose the objects of this class and objects of this class, which are two different classes, suppose we wanted to use one reference to refer to either one. And we'd like to just print out its value. We'd like to just say, I don't know if I'm referring to one of these objects or one of these objects. I really don't care. All I care about is calling the print method. The print value method. I'm not going to call the print numerator method because it may not be referring to something that is a numerator. But what we can do is we can take the methods that this class and this class have in common, if they have something in common, and we can create, now remember, methods are used to interface with the object. You could have a method that sets its value, like these constructors set values, and we can have methods that tell us what the value, retrieve the values. So we could have a method that retrieves values, we can have a method that sets values, but methods basically interface with the object. You set values and you retrieve values. And you perform operations on the objects. So methods can be kind of considered an interface to the object. So what we have here is we have something that is very similar. It's very similar to a class definition, but it's very limited. It's much more limited than a class definition. An interface is basically a list of method names with no bodies to them, because we don't know how to implement them at this level. We know at this level how to implement, we know how to print a value of a ratio. It's the numerator divided by the denominator, and we know how to print the value of an integer by just printing it out. But how you would print it would depend on the object you're talking about. If we're creating an interface that has just methods, and a method in this case would be like print the value, we don't know how to do it at this point, but we can just say the method name. We can say there will be a method called print value. We don't know the body of the method. We don't know what it does. We'll let each individual class define how that's done. So what we're doing in an interface is we're just listing a collection of public methods. There are no private methods. It's a collection of public methods, and there's no data in an interface. All it is a list of methods with no body. And then, what value does this have? Well, it would be nice if we can create a reference of type printable, and then use that to maybe refer to a ratio, or maybe refer to an integer, or refer to anything that, as long as it has this print value method in it. So, when we declare an interface of named printable, and we can now build a list of methods. Right here, I'm trying to keep it simple, so we only have one method, but we could actually list more methods. Any class that implements this interface is making an agreement. It's like a contract. It's like saying, I guarantee I will supply these methods, and I will supply the body of it too, so if you call it, it'll actually know what to do. But I'll guarantee, if I'm a class and I declare I'm implementing this interface, then I am guaranteeing I will supply the bodies for all the methods in this class. So for example, the class ratio declares that it implements printable. That means any method listed in this list will be guaranteed to show up in this class. And so for example, the method print value is right here. And here's the actual body of the class. It tells you what it's doing. Same with the class myInteger, which also declares that it implements printable. That means in here, we are guaranteed that the method print value will be there. If you declare that you implement an interface and you forget one of these, there should be a compiler error. So let me comment this out and just see if we hit this compiler error. So for example, right now as this code stands, it should compile correctly. Okay, so there's no compiler error. But let's say, for example, we commented out this public void printable method. So it's like it's not here anymore. We've created a problem. We declared, when we created this class, we declared that we implement printable. What does that mean? We are guaranteeing that every method here will appear here with a body. But I just commented it out. So if I compile this now, we should get an error message that says something like what? Hopefully it's a good message, but it should be something along the lines of you've implemented printable, which has this method, and you haven't supplied the method. You know, something along those lines. Hopefully that'll be the error message. So if we compile this now, compiler.
We need one. Now you don't get.
Oh, did I save it?
Oh yeah, I gotta save it.
Okay. So, let's see, is not my integer is not abstract and does not override abstract methods. Okay, so an abstract method is a method where you declare it but do not give it a body, and you need someone to, you need whoever inherits from it, or in this case implements from it, to declare its body. So we said that my integer implements printable. There was a method here that, an abstract method, meaning you declared its header but you didn't give a body, so that's an abstract method. But we didn't go and implement it, so that gave us that compiler. So let's take that comment out and bring it back to life. Save it, and then it should, okay, so it should now compile, which is the way we had it before. Okay, so it compiles okay. Now, what is the code doing? Go back up to the main method. The code is saying, okay, I printed out something to let you know it's the print value function. We're creating 3 ratios. We're declaring 3 ratios. So this is a reference to a brand new object, creating a ratio. We're creating a ratio passing in no information. So that will create a chunk of storage. By the constructor, is it still on the screen here? The constructor of a ratio that takes in no parameters will set the numerator to 0, the denominator to 1. The second one, R1, so R0 will end up being 0 divided by 1. R1 passes in 1 parameter, so that calls this constructor, the one that takes in 1 parameter, sets whatever number we pass into the numerator and sets whatever the denominator will be set to 1. So in this case, this will do a 1 divided by 1, will be the second ratio. Then R2 will call the third constructor, the constructor that takes in 2 parameters. A 4 comes in as x, a 2 comes in as y. The numerator becomes 4, the denominator becomes 2, so the overall value of the ratio is 2, right? It's 4 divided by 2, but its value should be 2. Then we decided to create 2 integers. So basically, these 5 lines exercise all the constructors that we have, because an integer has 2 constructors, one that takes in no value, which we said the value will be set to 0, and then one that does take in a value, which we will take the value and assign that, right? So we have an integer of value 0 and an integer of value 1. So we've created 5 objects, and we have a ratio whose value is 0, a ratio whose value is 1, and a ratio whose value is 2. And then we have an integer whose value is 0 and an integer whose value is 1. So I'm kind of using the names, which hopefully they will end up equaling the values. We can explicitly pick any of the objects and call these methods. These methods didn't like somehow get tied up with the interface. They're free methods that the class can use. So we could call them directly and it'll print out the values. And maybe what I could do is I should also print out the values of the integers, like explicitly. Well, the interesting thing, the part with the interface is we now have like a new, it's almost like a class, an interface. It's a new type. So we have a type called printable. It's a thing that can be printed. It's not a ratio, it's not an integer. It's, all it is any object that has a method called print value. Any object in the world that has a method called print value is considered a printable. So we can now create references of type printable, and it could refer to a ratio, and it could refer to a my integer. It could refer to objects that are of types other than printable. All printable really is an interface. So at this point, we've now created an array of 5 elements, numbered 0 through 4, and we've taken some ratios and assigned it to to those values, and we've taken integers and assigned it. Now we have a mixture of types. So printables can be of any object that implements printable can be referred to by a printable object. Does that make sense? So the idea is that an object of type printable can refer to any object that implements printable. So the 0, the first, and the second one refer to the 3 ratios, the third and the fourth, number 3 and 4 refer to the 2 integers. And now this code will go right through the whole array and just call the print value function. And they'll all get printed out. So let me, why don't we run this and see what the output is.
This makes a lot more sense than what you were doing last week. with the
Oh, okay.
board.
Yeah, I was trying to get as simple an example as possible. Okay. I don't know if the, okay, so this is the output of the code. What I'm trying to demonstrate is just because we made an interface and threw in the method print value, did not somehow subtract out the method print value from the class. You can still use it the normal way, but you could also use it as using a reference of a printable. So the output of this, here we took ratios 0, 1, and 2 and printed them out directly, their values. And this actually, this 2.0 was really the 4 divided by 2, got moved over to the float, and then we printed out the float. Then we went through the array and started over again. We started over again, and we printed, this is the first ratio, the second ratio, the third ratio, then the first integer, and then the second integer. So these 5, these last 5 were printing out objects of type printable. Now it turns out the first 3, yeah, I'm trying to think if, maybe, yeah, let me take out the first 3. Let's just make things confusing. Let me go. Okay, so this is just the 5 that got printed out. So these 5 right here, these 5 objects, because I took out the when I was printing them out directly. So these are just the objects from the array printable. And the array of type printable had a mixture of stuff. It had some ratios and some integers. Didn't matter, as long as they all have a method, called print value, their values would come out. So let me just slide this over. As long as they had a method called print value, you can use a printable reference referring to an object as long as it had a method called print value, and it will get called. Now, what we could have done up here, because we're referring to a reference by its name, we could call the print numerator method. That'll work fine. So let me just do that. So let's say, the interesting one would be the third one, right? So if we said this, if we called print numerator. What's that? Oh, okay. So if we said, okay. So now what I did was this, I added one line since the last one. I said, take R2, now remember, ratio 2 was 4 divided by 2. 4 is the numerator, 2 is the denominator, right? That's how we created it, 4 divided by 2. I can take that object, because this is of type numerator, this is of type ratio. A ratio has a method called print numerator, and will print out the numerator. So I can use this thing, I can use a numerator reference and call the print numerator method, because all numerators have a print numerator method. But what if I came down here and said, go through all the printable objects and call the print numerator method? What would you expect to happen?
Error?
An error, because what do printables have? All they have is a print value method, nothing else. If you start asking for other methods it don't know about, it's gonna blow up. So this should give me a compiler error. If I take that comment down, this should say, so in this case, what I'm now trying to do, see if this message is clear. Cannot find symbol print numerator in the interface. I don't know if that's I guess somewhat clear. But here, what I'm trying to do now is I'm saying these objects which are of type printable, and the only thing a printable has is a method called print value, nothing else. If you start asking for methods that it may or may not have, it can't let it go through, because some of these printables refer to ratios which have the print numerator method, and some of these printables refer to my integers which do not have that. So when we got to when I became 3 and 4, and we called the print numerator method on an integer, it doesn't have a print numerator method. Now, why don't we add a print numerator method to the my integer, and then also add it to the interface, to show that we could do, this will demonstrate that an interface can have more than one method. So suppose we did this. Suppose we said, what is a print numerator method? It's a void print numerator. It just prints out the method. So we can do this. We're going to add a second method to the interface called print numerator. Now what would happen if we compile this? Okay, let's think about this. We've added to the interface printable. We've added, it now has two methods. One is called print value, which prints out the value of whatever it is. And then we have a second method called print numerator. So apparently, whatever these things are, they not only have a value, they also are guaranteed to have a numerator. But any class that implements printable, we are guaranteeing both of these methods with their body. The body of the method will be there. Now, in ratio, we have print numerator with a body, and we have print value with a body. That's good. What about my integer, which claims to implement printable? It claims both of these methods and bodies are there. Is that true?
No.
Because my integer does not have a method called print numerator. So we should get an error something like that if we compile this now.
Well, then you saved it.
What's that? Oh, I didn't save it. Yeah, it's like the same error. My integer is not abstract and does not override the method print numerator. Okay. That's a real clear message for you. But anyway, let's add a method under the class my integer. Let's add a method called print numerator. As long as the method, if we claim we implement it, then we are guaranteeing the method will be there, and that's why we just got the compiler error, because it wasn't there. So if we say print, and what is the numerator of an integer? It's whatever its own value is, right? So we'll just print out the value. An integer's value is whatever it is, and its numerator is whatever it is, right? Now the method's there. So now it should compile.
It's in a bracket.
What's that?
After.
Oh, okay.
Yeah.
Let's just cut and paste. Well, we're missing a character. Okay, so now, for every, no, let me just make it. Okay, so for every value that we have, okay, so, what are we printing out? Okay, so this is what we're printing out. The output of our program is, okay, well, we left in that line, printing out the numerator of R2, that's why 4 came out. So, yeah, that's why the 4 came out. We said, let's take R2's numerator, so that's that 4. Then we went through the printable array and we said, well, we loaded these values in. Then we went through the array, we said print out the value and then print out the numerator. So what we have for the first ratio, the value is 0.0. That's what we converted over to a float. Then we printed out its numerator, which was 0. Then we printed out the value of the second ratio, which is 1.0. Then we printed out its numerator, which was 1. So that must have been 1 divided by 1. Then we printed out the value of the third ratio, which is 2.0. And then we printed out its numerator, which is 4, because that was 4 divided by 2. Now we switch over to the integers. We printed out the value of the integer, which is 0. Then we printed out its numerator, which is this new definition. We said that an integer's numerator is itself. And then we printed out the 1 and its numerator, which was 1. So we were able to call these methods because all of these methods definitely exist in the printable interface. So the printable interface, an interface is basically a list of public-only methods. Like, remember, some methods can be public or private or protected, but in an interface, they're all public. Think of it, and why would it have to be that way? What if you had an interface that had a couple of private methods? And nobody can get to them, so how could you implement something that nobody can get to, right? So it only makes sense that in an interface, everything would have, all the methods would have to be public. Now, what would happen if we decided to put some storage in an interface? Suppose we said that the interface not only has some abstract methods, but it has an integer field. Okay. So the let me see if I can change that here. So some variable, we get a variable called z, and I'm going to print that. So they all have a z. I don't think how to make a use of this. You know, let me leave this topic out for now. I was going to have static methods for variables in the interface, but we'll leave that out for now. So, the fields in the methods in the interface are guaranteed to be implemented by any class that implements that interface. You can now create a reference. It doesn't have to be an array too. This could have just been, let me just demonstrate that. It didn't have to be an array. We could just say, we could say, pref equals R2, and then you would say pref dot that should work, right? So we've really added one more 4 should come out. Now let's see if we find where it is. So we had, that's the numerator, first one, then first, second, third, first, the second, and then the 2.0. This is new, the 2.0. That came from the printable reference referring to object 2, and then we call printable references print value function here. So that's where this extra 2 came from. So I just wanted to demonstrate here, it doesn't have to be array fields, it could be any reference, but that's usually where it's going to end up being, because now you're typically saying you have 2 different classes, but they have something in common with each other. Now that sounds a lot like a base class, right? Remember when we were chatting about, like, if we had a class called electronics, and then from that we can have an electric clock and electric radio, which inherit from them. So if there's 2 classes that have something in common, usually the design is to put the things that are in common into a common class and then inherit from that. But since Java doesn't allow multiple inheritance, if the things that are in common are just an interface, just a way of talking to them, not having actual values, like we said, the radio would have like a volume knob and a radio station value, and a clock would have hours, minutes, and seconds. If you didn't have data fields, and the only thing that they had in common was the way you interface with them, just methods alone, you can have this common. It's not a class that you inherit from, but it is a collection of methods that they all have in common. We can create an interface, and then have all the classes implement that interface, and now we can create object references. We can create references like this. A reference to, this is a reference of type printable, and this is a reference of type ratio. But we can say a reference of type printable can refer to an object of type ratio, and then start calling any method that's in the interface. So it's pretty close to saying we have a class called printable. We have a class called printable. We have a class called printable, and ratio and myInteger inherit from it. But it's not quite true, because a class could have data fields and private methods and a lot more than an interface. But when you implement an interface, at least there's some commonality between the 2 types. Commonality in the sense that you have those methods are the same. And now the other thing we can do, we talked about inheritance before. If, for example, ratio inherited from something, we could have objects of the type that it inherited from, and call methods that appeared in that base class too. It's the same concept. So the concept of inheritance and implementing an interface is whenever you have an object of a certain type now, like this is of type printable, you can only call the methods that make sense for this type. Not, you can't say, well, I know this object has a print numerator, method. If this didn't have it, you wouldn't be able to call it, like we did before. When we had the compiler error, when we called the method and it wasn't part of the interface, we had a compiler error. So, any questions about this topic? And it's, again, like I say, it's the same thing, it's gonna be the same concept. It's the topic of, they call polymorphism, is where a field, a reference, can refer to objects that are of its own type or similar types. Not just anything, but similar types. So for example, this is a reference of type printable, but it's referring to an object of type ratio. They're different types, but they have something in common. What do they have in common? The methods that are listed in the printable interface. So you can refer to, it's okay to have this type mismatch as long as you only refer to methods that this thing can understand. What other compiler error could we cause? Just to, yeah, I think we hit all the interesting ones, right? When we added a method to the interface that wasn't in the class, we got a compiler error. And then when we referred to methods that were in a class but not part of the interface, it said, no, you can't do that using a printable reference to refer to a method that only exists in ratios. Okay. And we can refer to the methods directly, like in this case. We can take the object directly and we call it, or we can do it through printable. Okay, so any other question on this topic? That's good.